In the mid-1920s, when biplanes reached their heyday, the air forces of many countries paid great attention to developing two-seat single-engine fighters and multi-role aircraft. In terms of speed and maneuverability, they were hardly inferior to single-seat biplanes. This was made possible by the high level of structural refinement achieved by that time. The additional drag from a gun turret and an observer, together with increased wing area and the aircraft's overall mass, were negligible. It was believed that a two-seat fighter had certain advantages. The presence of a gunner or navigator provided greater versatility in combat employment. Such aircraft could operate as fast reconnaissance planes, night fighters, light bombers, and attack aircraft. When escorting heavy bombers, they did not need to perform complex maneuvers or break up the strike group's formation to repel attacks by enemy fighters from the rear hemisphere. A movable gun installation protected the fighter from the rear and increased the duration of target fire in a single attack, which was especially important for night interceptions and for destroying small ground targets. The first two-seat fighters in the Soviet Union were developed under the leadership of Nikolai Nikolaevich Polikarpov in the second half of the 1920s at the Moscow Aircraft Factory. Later, this work continued at the Central Design Bureau of the Menjinsky Factory. In the summer of 1931, they built a mixed construction biplane there, and in early 1933, a metal high-wing aircraft by the French designer André Leville. All of them remained as experimental prototypes. A logical continuation of this direction at the Central Design Bureau was the creation, in the summer of 1934, by the brigade led by Sergei Oleksievich Kocherygin, of a two-seat biplane. The direct design of the aircraft was handled by the future well-known aircraft designer Vladimir Pamfilovich Yatsenko. Behind the recent graduate of the Moscow Aviation Institute stood a long life and professional experience. After graduating from the Kursk Real School in 1915, Vladimir Pamfilovich served in the Army as an aircraft mechanic and motor mechanic, and worked as a designer at aircraft enterprises of various designers. Since 1924, at the first factory under the leadership of Nikolai Nikolaevich Polikarpov, Yatsenko developed fuselages for various aircraft. In October 1929, he was appointed lead designer at the Central Design Bureau. In the autumn of 1931, Yatsenko headed a newly formed design group for two-seat fighters that worked at the Experimental Designs Factory. The next year, after another structural reorganization of experimental aircraft construction, Vladimir Pamfilovich Yatsenko's group was merged into the Brigade of Attack and Reconnaissance Aircraft under Sergei Oleksievich Kocherygin. The new aircraft was designed from the start in two main variants, a two-seat fighter and an attack aircraft. For the two-seat machine to become a full-fledged fighter capable of maneuvering aerial combat, the designer had to ensure power-to-weight and wing loading figures close to those of a single-seat fighter. This could be achieved by a very meticulous approach to the overall layout of the fighter. Frontal aerodynamic drag was reduced by equipping the new biplane, for the first time in world practice, with retractable landing gear. At the same time, the shock absorbers were placed in the hubs of the main wheels. In the attack variant, in addition to 4 underwing hardpoints, a bomb bay in the fuselage was provided for 4 aerial bombs, weighing up to 22 pounds each. 2 containers for chemical armament could be suspended on the wing nodes. The gun armament also differed. The fighter had 1 turret and 2 wing-mounted machine guns with an ammunition load of 750 rounds per gun. The attack variant had 1 turret machine gun with an ammunition load of 750 rounds and 4 wing-mounted machine guns with a total ammunition load of 3,000 rounds. When overloaded, the wing gun's ammunition increased to 4,000 rounds. The use of different machine guns on the fighter and the attack variant is explained by the specifics of the machine's employment. Lighter, faster-firing machine guns, rate of fire 30 rounds per second versus 13 rounds per second for the heavier models, were used to engage small and fast airborne targets when firing was conducted at almost constant range. Heavier machine guns, which at that time were more reliable and 5 times cheaper, were used to fire at slow-moving area targets from various distances with longer bursts. To increase firing effectiveness, 2 of the wing machine guns were mounted in a converged fan arrangement, and 2 were mounted parallel to the longitudinal axis of the aircraft. To provide the pilot with a good view of the rear hemisphere, the gunner's enclosed cockpit was placed below the pilot's headrest. Initially, the aircraft was planned to be equipped with a V-type liquid-cooled engine developing 600 horsepower, designed by Vladimir Mikhailovich Yakovlev. This engine was intended to operate at altitudes up to 16,400 feet. 6 experimental engines operated on test stands for a total of 200 hours during 1932 and 1934. But serious structural defects were revealed during testing. Pistons burned out, valves broke, and bearings failed. Therefore, the development of this engine was discontinued. Because of the failure with the first engine, during the review of the fighter's sketch project and mock-up, it was replaced by a less high-altitude air-cooled radial engine, the Wright Cyclone, producing 625 horsepower. This engine could operate only up to 7,000 feet. In September 1934, the first experimental aircraft with red wings arrived at the Air Force Research Institute for preliminary state trials. From the institute, the lead test pilot assigned was Ivan Fedorovich Petrov and the navigator Vinogradov. From the factory, test pilot Yuri Ivanovich Piontkovsky and the head of the flight test station Nikolaev participated in the trials. The first flight of the aircraft was carried out by the test pilot of the Research Institute, Andrei Ivanovich Filin, only on September 30th. The second flight took place in December. During this time, the aircraft had its engine replaced, the stabilizer installation angle adjusted, and the retraction and extension of the landing gear regulated. But on December 10th, the novelty of aircraft construction, the retractable landing gear, reminded of itself. During that flight, the locks of the struts did not close in the retracted position. Pilot Petrov applied pressure to the system before the locks of the extended position had opened, which deformed the strut drive lever. The next day, while approaching to land, he could not lock the landing gear struts in the extended position, and the pilot landed the aircraft on its fuselage. The flight incident, blaming the pilot for everything, was reported to the People's Commissar of Heavy Industry, Sergo Orjonikidze. Grigory Konstantinovich summoned Petrov for an explanation and listened attentively to the test pilot, delving into the essence of what had happened. Returning to the institute, Petrov learned that by order of the commissar, he had been commended and awarded a passenger car. In the test report completed later that same month, it was noted that due to engine shaking at certain operating modes, the lower wing consoles vibrated, especially the left one. The nature of the vibrations indicated resonance between the natural oscillations of the wing and the engine's shaking. During takeoff run, the tail was hard to lift, and there was a tendency to turn left, which on an uneven airfield made it difficult to keep the takeoff direction. Using the emergency landing gear extension system required great physical effort from the pilot, and due to insufficient aileron efficiency, the aircraft entered turns slowly and changed direction sluggishly. A pilot in winter gear with a parachute could not climb into the cockpit without outside help. Matters were no better when abandoning the aircraft in an emergency in flight during winter. The navigator was dissatisfied with the lack of communication with the pilot, especially at high altitudes and when the engine operated at maximum power. Poor visibility from the cockpit downward and forward in flight was noted, as well as limited firing angles of the rear gun mount. In an emergency situation in flight, the navigator could hardly leave the aircraft because of the small hatch opening and the considerable physical effort required to unlock the left hatch leaf. The overall conclusion about the machine was favorable, and in particular it stated, "The obtained speed, maneuverability, and absence of major defects show that this two-seat fighter can quickly be brought to standard condition and will be of great interest to the Air Forces as an aircraft possessing good flight characteristics. It is necessary to accelerate the construction of the second machine, bring it to combat condition, and submit it for state trials. At the same time, it is advisable to begin building an experimental military series of aircraft. Propose to the plant to work out the issue of modifying the aircraft into a single-seat escort fighter. The retractable landing gear and wheels with internal shock absorption are to be considered as having passed state trials. The layout and design of the gear and wheels should be recommended as a successful example. The first serious trial of the new machine was successfully passed. The designer's concept was embodied in winged metal, which in its main characteristics satisfied the customer. After the May Day holidays of 1935, the Research Institute began state trials of the improved two-seat fighter. This time the aircraft was tested by pilots Pavel Yakovich Fedorovi and Vladimir Andreevich Stepanchenok. After the completion of state trials in November 1935, the overall opinion of the aircraft among the participants and institute leadership remained positive. This two-seat fighter, for its class, has a read speed range, at an altitude of 9,800 feet from 93 to 239 miles per hour, good maneuverability for a two-seat aircraft, and stable diving. The problem of a biplane with reliably operating retractable landing gear has been successfully solved. The wheels with internal shock absorption are well made, the wing-mounted machine gun installations operate flawlessly, gun control and aiming are convenient, the manufacturing quality of the aircraft is overall good. During the tests of the gun armament, the fighter pilots practiced tactical methods of employing the new machine. Several pages of the test report contain detailed diagrams of attacks on air targets and defense against enemy fighters, convincingly demonstrating the tactical advantages of the two-seat aircraft. However, new technology always has its drawbacks, and this fighter was no exception. Here are the main problems included in the state test report. Due to very limited firing angles and the difficulty of controlling the gun mount, it was easy to shoot through the tail section of the aircraft. The design of the gun mount did not provide for proper maneuverability and uninterrupted operation of the gun. The gunner, seated with his back to the flight direction in an uncomfortable, tense position, quickly became fatigued. To retract the landing gear, the pilot had to perform 9 operations. The tail section and wings vibrated during flights at high angles of attack. Furthermore, during night flights, the pilot was blinded by the engine exhaust flames, which made aimed fire impossible and complicated landing. As before, there was no reliable communication between the gunner and the pilot. For a gunner with a parachute, leaving the aircraft in an emergency was difficult. Only the left half of the gunner's canopy opened. The small cockpit windscreen did not protect the pilot, the fuselage was drafty, and the crew froze during flight. There were no fewer remarks concerning the convenience of servicing the aircraft by technical personnel on the ground. The conclusions of the Research Institute of the Air Force received the backing of the head of the Air Force of the Workers' and Peasants' Red Army, Yakov Ivanovich Alksnis, who specifically asked the head of the main directorate of the aviation industry to oblige the factory to produce as soon as possible one of the 10 aircraft ordered for military trials as a prototype machine for 1936, with all defects eliminated, equipped with a radio station, engine autostarter, and other refinements. On the last day of October 1935, the factory submitted the first prototype in the attack aircraft variant for field and factory tests of the armament. A total of 10 flights were made. In 8 of them, the wing-mounted machine gun batteries were tested and functioned without failure. In 3 flights, bombing with bodies of aerial bombs was carried out on the range. In 2 flights, equipment for dispersing chemical agents was checked. But this proved insufficient, and Air Force Chief Alksnis decided to carry out additional armament tests of the assault aircraft with the involvement of the most experienced pilots from operational units. In particular, on a low-level flight, where the pilot's attention is concentrated on piloting technique, he could not carry out detailed orientation to reach the target. Orientation was not entrusted to the navigator, whose cockpit was blind, and therefore the main property of the assault aircraft, surprise, was lost. The range with full load, the number and quality of bombs did not meet tactical requirements, which made the aircraft inadequate for performing assault missions. The long takeoff and landing runs of the aircraft extremely complicated its operation from field airfields. At high speeds, the aircraft's nose rose sharply, and the heavy pressure on the control stick fatigued the pilot and prevented him from orienting himself by map. The bombing equipment, concentrated in the front cockpit, heavily burdened the pilot and complicated aim bombing because the aircraft itself obscured the target. The pilot-navigator took no part in the bombing. At the same time as the additional assault aircraft tests, in February 1936, the factory submitted 2 serial fighters for military trials. Until then, military trials of aircraft had not been conducted in Soviet aviation. These aircraft were the first on which the organization and methodology of military trials were to be developed and worked out. From the Research Institute of the Air Force, the military trials were led by the Air Base Commander of the Institute, Major Spirin. The test brigade also included the armament engineer Sorin and the chief test pilot engineer Anatoly Ivanovich Nikashin. In February, the first flight of a fighter on skis took place. Tests of the 2 aircraft on ski landing gear continued until 10th April 1936, when the airfield turned to mud and flights became impossible. The wheeled gear aircraft took part in the May Day celebrations. At the end of May, after completion of factory repairs, 3 fighters, a third joined the 2 initial serial machines, landed at the Research Institute of the Air Force Airfield, and military trials continued on them through June. During these trials, the Institute conducted single training air combats between this fighter and other Soviet aircraft, which showed that the most advantageous maneuvers were deep turns and combat reversals. Because its power-to-weight ratio was lower compared with single-seat fighters, this aircraft lost vertical combat to them. It outperformed the reconnaissance aircraft in vertical and horizontal maneuvers. The stall and spin characteristics of the fighter were also determined. Departure occurred at a speed of 50 to 56 miles per hour with full rudder and stick pulled into the spin. After 3 turns, the aircraft recovered with a slight delay. When the number of turns increased to 5, cases of improper spin were observed, from which recovery required large forces and occurred with a delay of 1.5 to 2 turns. In cases of significant delay, it was necessary to add power, after which the aircraft recovered from the spin well. This fighter flew easily in formation at medium altitude, and with difficulty at low altitudes due to insufficient effectiveness of the ailerons and forward visibility. The military trial report noted, in maneuverability, this aircraft even ranks above single-seat high-speed fighters. The presence of a rear firing position, together with the qualities noted above, gives it significant advantages in conducting air combat with all types of aircraft. However, a number of shortcomings of the rear gunner's cockpit reduce its combat value as a fighter. In June 1936, the main production model of the aircraft was delivered to the Air Force Research Institute. The aircraft still remained in the focus of the Air Force leadership, so its testing was entrusted to engineer Anatoly Ilovich Nikishin and pilot Ernest Yusufovich Preman. In 28 days, they completed 33 flights. In the 2 years since the start of testing of the first prototype, it had not been possible to improve its tactical and technical characteristics. The takeoff weight increased by 178 pounds due to the installation of additional equipment and modifications. The maximum speed decreased by 10 miles per hour, and the takeoff run length increased by 70%. It was not possible to eliminate the vibrations of the tail assembly at high angles of attack, and the firing angles of the rear gunner's position still did not satisfy the Air Force. What was striking in the reports was not the number of shortcomings revealed in the DI-6, but the fact that most of them were either not corrected at all or only partially corrected. This situation with the aircraft's refinement can partly be explained by the unyielding character of Yatsenko. People who knew him well said that he defended his decisions to the end. By that time, the DI-6 had already gone into production, so it was too late to retreat. This alone explains the following conclusion of Oksnis. The deterioration in the flight qualities of the production DI-6 aircraft noted in this report should be considered unacceptable. Aircraft whose flight performance is lower than that recorded on the prototype should not be accepted for supply to the Air Force of the Red Army. The head of the main directorate of the aviation industry should be requested by appropriate orders to instruct the factories producing DI-6 aircraft to eliminate all defects identified during military trials. By thorough processing of the aircraft to achieve an increase in speed, to strengthen the lower spar of the center section, to introduce a design modification that excludes the occurrence of vibrations of the horizontal tailplane. On aircraft already in service with the Air Force of the Red Army, prohibit parachute jumps, prolonged or deep slips, and rolls due to vibrations of the horizontal tailplane. Turns and spirals should be performed with a maximum bank of 60-70 degrees, more smoothly, avoiding sharp transitions and pulling the control stick abruptly. Loops should be performed without hanging. In the autumn, pilot Alexander Semyonovich Nikolaev, under the supervision of lead engineer Mikhail Ivanovich Tarakanovsky, carried out 5 flights to obtain an objective assessment of the static stability of the DI-6 aircraft, with center of gravity positions of 29.4 to 34.1% of the mean aerodynamic chord across the entire range of operational angles of attack. The conclusions from the tests noted that the aircraft with the control stick released during gliding trimmed itself at high speeds, which was undesirable from the standpoint of flight safety, and with the landing gear extended and the rudder locked, it exhibited spiral instability. With the rudder free and the landing gear extended, the stability margin was negligibly small. With the rudder free and the landing gear retracted, the aircraft was laterally stable. In 1937, production DI-6 aircraft began to enter combat units, while the Air Force Research Institute continued work on improving the aircraft. In June of that year, the first DI-6 produced by one of the factories arrived for military trials, during which a number of design flaws were revealed that had not been corrected since the first prototype. In the autumn of that same 1937, Nikishin began state trials of a production DI-6 built by the 8th factory. It differed from the prototypes by the installation of an Eclipse electro-inertial self-starter with a battery and generator, a radio station, an intercom system, welded fuel tanks, and a modified fuel system, a new type of oil radiator, and cast wheels. The engine cowling was improved. Louvers were installed at the intake, and an inner cowling was fitted for the units located behind the engine. The mounting of the gunner's canopy screens was changed. In case of emergency, both panels of the rear cockpit could be jettisoned. The aircraft was equipped with an air screw 9.2 feet in diameter with a new spinner. The firing sector of the rear gun mount in the upper hemisphere in the vertical plane was increased from 25.5 to 58.5 degrees. The spar of the lower center section and the pilot's cockpit floor were reinforced. Additional equipment increased the aircraft's takeoff weight to 483 pounds and the center of gravity to 30.5% of the mean aerodynamic chord. The aircraft's weight increased by 350 pounds compared to the Design Bureau prototype and by 176 pounds compared to the production model from the first factory. During state trials of the production aircraft, the range was determined with a takeoff weight of 4,483 pounds, a fuel load of 357 pounds, with 33 pounds remaining. In particular, at an altitude of 3,346 feet and a speed of 137 miles per hour, it amounted to 286 miles. And at 18,865 feet and a speed of 155 miles per hour, it was 321 miles. Communication remained unsatisfactory, both with the ground and between crew members. The test report also noted the insufficient effectiveness of the ailerons at speeds below 124 miles per hour, the fire hazard of the fuel tank drain vent near the exhaust manifold of the upper engine cylinders, the exposed layout of the control cables in the rear cockpit into which the flexible ammunition feed hose of the rear gun mount could easily fall and jam the controls. Incidentally, this did happen on one of the machines before a flight from the factory to the Air Force Research Institute. In December 1937, pilot Nikishin and test pilot Sokolov completed the state trials of the improved production DI-6, which differed by an engine with a takeoff power of 775 horsepower, a horizontal tailplane lowered down, aileron area increased by 2.7 square feet, an acoustic signal system for retraction and extension of the landing gear. The wheel brake control was transferred to the aircraft control stick, factory-designed wing machine gun power units were used, and the upper center section tanks were reinforced. As a result of the downward displacement, the rigidity increased and the amplitude of horizontal tail vibrations decreased. Its effectiveness during takeoff increased. The aircraft could now easily lift its tail at the start of the run. Controlling the wheel brakes from the control stick became more convenient than from the pedals. The relocation of the stabilizer hardly changed the firing arc of the rear gun position. Many of the problems noted earlier still accompanied this two-seat fighter. The upper reinforced central fuel tank leaked. Because it was mounted incorrectly, the hatch above its opening tore off in flight with the subsequent loss of the fabric covering. The skin on the lower surface of the upper central wing section peeled off. The pilot's cockpit folding sides and many other items drew complaints. Despite the latest increase in the empty weight of the modification, its flight characteristics approached those of the first prototype. Slightly inferior in maneuverability, this model did not lag behind the previous version in maximum level speed. After 60 years, one must respect the conscientious work of the test pilots of the Air Force Research Institute. The persistence of Air Force leadership, which despite a severe shortage of high-speed combat aircraft, consistently defended the interests of the Red Army and tried to supply the Army with the aircraft it needed rather than what happened to be available, is noteworthy. Therefore, the concluding recommendation of the test report, which proposed that after correction of the detected defects, a small number of aircraft with the low-mounted stabilizer be produced, stated, requests the Main Directorate of Aviation Industry to take all measures within its power for the quickest modification of the aircraft so that in the first half of the current 1938 year, an aircraft with elimination of its main defects be delivered for testing. In January 1938, the final variant of the two-seat fighter arrived for testing. The aircraft had been designed for an engine with a variable pitch propeller. By the time the prototype was built, that engine had not arrived at the factory, and the fighter was fitted with an engine with a fixed-pitch propeller of 9.2 feet diameter. The new variant differed from the production machine by a simple landing gear, a common canopy covering both pilot and navigator cockpits, a new engine cowling with skirts, the absence of upper wing tanks and increased capacity of the fuselage tanks, the placement of the wing machine guns above the wing and the ammunition chests in the lower wing, a modified rear firing station construction, mechanical brakes with pedals at the foot controls, and a pressure priming system for engine start. The lower wing was equipped with split flaps. The test report noted a reduction in maximum speed near the ground by 10 miles per hour and at an altitude of 9,800 feet by 18 miles per hour. Rate of climb and maneuverability remained practically unchanged. Takeoff characteristics noticeably improved. Takeoff became easier. The tendency to swing left during the takeoff run disappeared. Landing with the split flaps extended became more difficult. The glide angle during the approach became steeper, the landing more fleeting. The aircraft hung on the control column. Aileron effectiveness was judged sufficient. The wing gun mounts passed tests without remark. Complaints were raised about the installation of the ammunition chests through the lower surface of the wing. The vertical firing angles of the rear gun position increased with the redesigned sight, while the horizontal angles remained the same, and that only with the side panels of the canopy removed. The skirted cowling provided a stable engine temperature regime, but the control drive design for the skirts was considered poor. As before, both cockpits of the aircraft provoked many complaints. There were enough defects, thus the lines of the report read like a final verdict on the two-seat fighter. The aircraft with the preliminary engine has low speed and climb figures. Installation of the new engine with a variable pitch propeller while improving flight data still does not provide the values of speed and climb required by the technical specifications for this aircraft with the new engine. Even with the new engine, the aircraft is significantly inferior in its characteristics to contemporary two-seat fighters, approaching more the figures of so-called multi-role aircraft. Due to the peculiar arrangement of equipment, armament, and crew in the second cockpit, the aircraft cannot be used for another purpose without reworking the second cockpit. The aircraft, mastered in production by the factory, given its good takeoff and landing characteristics, visibility, maneuverability, and relatively acceptable flight data, is advisable to use after reworking the second cockpit as a transitional trainer and training aircraft when introducing new types of single-seat fighters on maneuvers, and for removing and training flight personnel for high altitude and night flights, and as a military reconnaissance aircraft. Request the Main Directorate of Aviation Industry to oblige the factory to urgently present a mock-up of the second cockpit of the aircraft in the variants of military reconnaissance and training trainer aircraft. Construction of the second prototype was halted in 1938 due to the absence of the required engine at the factory. After adoption of the two-seat fighter into service, the Air Force Research Institute continued to develop recommendations for the operational units on its safe operation and on increasing its combat effectiveness. In September 1937, test pilot Mikhailo Alexandrovich Nyuktikov investigated wheels with internal shock absorption on an attack aircraft. In the summer of 1938, military testers, pilot Golishev and navigator Ignatius, on a factory production aircraft with a high-mounted stabilizer, investigated the aircraft's aerodynamic characteristics in dives and bombing. From dives at angles from 40 to 90 degrees. For this aircraft, it was recommended to enter the dive from an altitude of no less than 8,200 feet. The altitude loss in doing so was about 7,020 feet. And to smoothly recover from the dive with G loads of 3.5 to 6 G at a speed not exceeding 280 miles per hour. It was noted that in a dive, the aircraft is not prone to going into negative angles, obediently follows control inputs, and has a tendency to swing left that is easily countered by the rudder. No vibration of the tailplane or wings was observed during diving. In the conclusions of the assault aviation regiments armed with I-15 BAS fighters, it was recommended to use DI-6 aircraft at the first stage of training and combat preparation for dive bombing. The presence of a second cockpit made it possible to check and train personnel in determining dive angles and counting dive time. In the second half of 1939, the DI-6 was already considered by the Air Force Command only as an attack aircraft. but the maximum bomb load of 88 pounds, as noted back in the 1935 military trials report, was clearly too small. By the fall of 1939, an aircraft with such armament could hardly be considered an attack aircraft. To increase the bomb load in October, tests were conducted on DI-6 and I-15 Bias fighters with aerial bombs weighing 44 and 55 pounds. The Soviet Air Force leadership placed high hopes on the two-seat fighter. The first 3 production aircraft were still undergoing trials at the Air Force Research Institute, and 7 others were delivered in October 1936 to the 56th Fighter Aviation Brigade of the Kiev Military District, which at that time had 25 pilots trained to fly the DI-6I. In November, in this aviation brigade, one DI-6I experienced a propeller blade failure during takeoff after 40 hours of operation. A similar incident occurred in flight on an I-16. During a pre-flight inspection of a DI-6I in November 1936, a transverse crack was also discovered in a propeller blade with 30 hours of use at the Air Force Research Institute. The causes of the propeller failures were linked to microcracks formed during hardening and cold straightening of the blades. After the plant strengthened technological discipline, such cases were no longer recorded. In the summer of 1936, experimental exercises on air combat of mixed formations were held in the Leningrad and Belarus military districts, with the main task being the development of tactics for fast aircraft, I-16, SB, and DI-6 in solo, group, and mixed battles. Maneuvers and combat command of mixed formations were practiced. Air battles were conducted at altitudes of 9,800, 16,400 feet, while assault aviation actions were limited to an altitude of 65 feet. At the same time, tactical methods of air combat used by the French Air Force were practiced. The untimely delivery of DI-6 fighters and SB bombers to the troops did not allow the planned program to be fully worked out, and the completion of this work was postponed until the following year. In 1937, Factories 1 and 81 planned to produce 61 and 51 DI-6 aircraft respectively. They were intended to equip a number of squadrons in several military districts. In the training and combat preparation reports of the Kiev Military District Air Force for the 1936-1937 academic year, it is noted that in the summer of 1937, the 53rd Long-Range Fighter Squadron conducted 3 group exercises and a wargame on the theme covering the offensive march of a cavalry corps. Retraining in the 56th Fighter Aviation Brigade was slowed by the lack of DI-6 aircraft with dual controls, the small number of DI-6s, and an incomplete pilot staff. The 55th Long-Range Fighter Squadron of the Leningrad Military District was still in the formation stage and had no pilots. Since the possible use of chemical weapons by potential Soviet adversaries was not excluded, the Soviet Air Force training program included preparing personnel for warfare involving their use. Among the units armed with DI-6, the 114th Gomel Assault Aviation Brigade was trained for chemical warfare. In July 1936, it participated in training exercises at the Central Military Chemical Range, where it gained considerable practical experience in the use of combat toxic agents. As of October 1, 1937, there were 28 DI-6s in Air Force units. Of the DI-6 aircraft produced in 1938 by Factory 81, 6 were planned to be allocated to the Navy Air Force. In addition to the DI-6s already available at military educational institutions of the Air Force, 3 more were delivered by March 15, 1938, and another 10 were scheduled for transfer by the end of the year. In October 1938, the 52nd Omsk Assault Aviation Brigade was inspected by a commission of the commander of the Volga Military District Air Force, which noted that the brigade, using its own resources, equipped DI-6 aircraft for high-altitude bombing, for which they were completely unsuitable, and is successfully employing them. Attention was also drawn to the inventive work of the brigade's engineering and technical staff. Among the valuable inventions and rationalization proposals were a conical mount, fittings for photosyn machine guns, and sight pads for the OPB-1 bomb sight for the DI-6. In 1938, while mastering the DI-6, the brigade logged 9,867 accident-free flight hours on 29 aircraft. At the same time, during an inspection of the DI-6, the commission discovered play in the tail assembly and wing box struts on aircraft in operation, grounding 2 DI-6 aircraft. The commission stated that the DI-6 cannot be considered an attack aircraft because it lacks a radio station, has an insignificant bomb load, lacks suspended aerial cannons and rangefinder automatic sights, and finally, it is not suitable for low-altitude flight. It is blind. During the autumn inspection by the commander of the Belarus Special Military District Air Force of the 114th Gomel Assault Aviation Brigade, it was noted that the 14th Assault Aviation Regiment had 60 DI-6 aircraft, of which 6 were unserviceable. During the reporting period, the regiment had 8 accidents and 27 breakdowns caused by pilots, occurring during landings and rollouts. The 14th Assault Aviation Regiment was trained for combat operations in squadron formation only during the day. The situation with pilot technique checks is completely unsatisfactory. There are no DI-6 aircraft with dual controls at all. In October 1938, during a formation flight shortly after takeoff at an altitude of 164 feet, junior pilot Mitrofanov of the 14th Assault Aviation Regiment, instead of switching the fuel supply from the lower tanks to the upper ones at the leader signal, shut off the fire valve, cutting off fuel supply to the engine. The pilot landed on a meadow with the landing gear retracted at high speed. The aircraft overturned and crashed. According to the official plans of the Air Force of the Red Army at the beginning of 1939, it was intended to keep 60 DI-6 aircraft in fighter aviation and 64 assault variants in service. However, during that year, a gradual withdrawal of these aircraft from active duty began. Therefore, the claims sometimes found in literature about combat actions of several DI-6 squadrons near the Khalkhin-Gol River and their shooting down of 2 Japanese fighters in aerial combat are most likely a beautiful legend. From May to September, none of the operational units of military aviation equipped with these machines participated in air battles. The same can be said about the participation of the DI-6 in the war with Finland. Among the shot down, damaged, and crashed aircraft that took part in the Winter War, the DI-6 was not observed. The DI-6 aircraft served in operational units for a short time. By the fall of 1939, many squadrons armed with the DI-6 began retraining on the newer I-15 fighters. After 2 years of operating these fighters in the Kiev Special Military District, in the summer of 1939, it was concluded that they were more expedient to use as reconnaissance aircraft. So the 5th and 8th squadrons began to be referred to in documents as 2-seat reconnaissance squadrons. As reports on combat training of units armed with DI-6 aircraft show, the main flying time for them was at medium altitudes in normal weather conditions. At night, flights were made at high and medium altitudes, usually by individual crews and on other types of aircraft. In the fall of 1939, the 6th Assault Aviation Regiment of the 52nd Omsk Aviation Brigade of the Siberian Military District, which had 63 DI-6 assault aircraft, 8 of them unserviceable, began mastering the SB bomber. Out of the 173 DI-6 aircraft with the M25 engine available as of January 1, 1940, it was planned to leave 39 aircraft in 2 operational squadrons with a standard number of 24 aircraft, transfer 99 machines to training schools, and write off 35 due to wear during the year. According to the Armament Department of the General Staff of the Red Army on July 1, 1940 in the Air Force, with a standard requirement of 87 units, there were 180 DI-6 aircraft, 42 of which were in unserviceable condition. In July 1940, the Deputy Chief of the Air Force, Pavel Vasilyevich Rychagov, sent a directive to the commanders of the air forces of all districts to transfer spare parts from untouchable reserves for a number of aircraft, including the DI-6, into current supply. This directive indicates that the DI-6 did not have long left in service with the Air Force. In October of the same year, the Air Force headquarters submitted to the Deputy Chief of the General Staff of the Red Army, Lieutenant General Smorodinov, a draft resolution of the Defense Committee of the Council of People's Commissars of the USSR, prepared at his instruction, on the exclusion of unfit and obsolete equipment from the aircraft fleet. This document, in particular, provided for writing off and excluding from the Air Force 13 DI-6 aircraft with the M25 engine unfit for repair, and removing from service and excluding from the fleet 80 DI-6 aircraft with the M25 engine requiring medium and major repairs. No evidence of the DI-6 being used for pilot training in higher educational institutions of the Air Force has been found, but their use as training aids in technical schools is confirmed by archival documents. In the 1939-1940 academic year, 4 DI-6 were used to practice skills in starting and checking the operation of the engine at the 2nd Leningrad Military Aviation Technical School, named after the Lenin Komsomol, 2 DI-6 at the Leningrad Aviation Technical Refresher Courses of the Air Force at the 1st Leningrad Military Aviation Technical School, named after Voroshilov, and 1 DI-6 at the Serpukhov Military Aviation Technical School. Obviously, these are the 6 DI-6 aircraft transferred to educational institutions in the summer of 1938 from the 2nd Long-Range Fighter Squadron, Shepetivka, of the Kiev Special Military District, and 1 DI-6 from the 132nd Mogilev Aviation Brigade. The history of the DI-6 is instructive in many respects, as it shows how laboriously the Soviet aviation industry became a truly science-intensive and advanced branch of mechanical engineering. The large number of shortcomings revealed during tests can hardly characterize the aircraft as one of the unsuccessful Soviet fighters. The most famous aircraft of that time had no fewer shortcomings. During the testing and operation of the DI-6, no catastrophes occurred. In terms of the number of accidents and minor breakdowns, it also did not rank among the leaders, unlike its more famous counterparts. It was simply that the development of two-seat single-engine fighters turned out to be a dead end in world aircraft construction, and in many countries it did not go beyond the creation of original but experimental machines. The aircraft was a sesquiplane of mixed construction with retractable landing gear, equipped with a 9-cylinder air-cooled M25 engine. The wing box consisted of upper and lower center sections, 2 pairs of consoles, and cross-shaped struts and wires. Both wings had 2-spar wooden construction with fabric covering. The airfoil of the upper wing was the Clark YH with a relative thickness of 10%. Slotted ailerons with a duralumin frame and fabric covering were mounted only at the ends of the upper wing by struts. In the center section of the upper wing, 2 fuel tanks of 20 gallons each were installed. The relative thickness of the center section airfoil decreased toward the middle. The center section was attached to the fuselage with 2 N-shaped brackets made of chrome molybdenum tubes. The fuselage had a truss-welded structure made of chrome molybdenum tubes. The rigid spatial truss was hinge connected to the engine mount and the lower center section. A duralumin framework for fastening the covering was fixed to the truss. Duralumin in the front part, up to the pilot's seat, and fabric further on. The pilot's cockpit was of the open type with a protective windscreen made of triplex glass. The seat was adjustable for the pilot's height on the ground. The gunner's cockpit, enclosed on 3 sides with celluloid glazing, had 1 triplex window on each side. The gunner had 2 seats. The main one faced the tail and was mechanically linked to the arc carrying the rotating gun mount with a Shk-S machine gun. The additional foldable seat on the right side allowed sitting facing the direction of flight. The cockpit fairing consisted of 2 halves connected by a lock along the longitudinal axis of the aircraft and could be jettisoned in an emergency. The left half opened when the gunner entered the cockpit. The aircraft's controls were simple and conventional with a cable system. The pedals could be adjusted to the pilot's height. The tail unit had a single fin with a fixed stabilizer. The stabilizer and elevators were made of a duralumin load-bearing frame with fabric covering. The elevators had axial balancing. The fin consisted of 2 parts, the lower one entirely metal on which the stabilizer was mounted, and the upper one with a duralumin frame and fabric covering. The rudder had no balancing and was made of a duralumin frame with fabric covering. The retractable landing gear was equipped with brake wheels measuring 29.5 by 4.9 inches, with internal oil pneumatic shock absorption. Retraction was performed by a rigid mechanism using compressed air. The retraction system also had a mechanical emergency manual drive for lowering the landing gear if necessary. The tail skid was non-steerable and fitted with oil pneumatic shock absorption.